graphs of Power Models exercise, what we're going to do is go through a bunch of slides where we have two equations and we have two graphs. And we say, do they match or do you need to switch? What you're going to do each time you get to a new slide is want to hit pause and try to guess for yourself, and then unpause to check your work. The first couple aren't really real questions. They're just to get used to the style of the video. So for example, what I mean here is, in this case, if we look at these two graphs, this graph is definitely the x squared graph. This graph is definitely 10 minus 3x. It's pretty clear that they're not switched. X squared, we expect to see this kind of open shape to it. And 10 minus 3x, we expect to see a linear equation with a negative slope and a y-intercept of 10. The next slide, don't hit pause either. That's just another one to get you used to the format of the questions. All right, so if we looked at this slide, and we looked at these two graphs, this does not look like x to the fourth. This does not look like x cubed. This is a case where we want to switch it. This goes with this. This goes with this, right? Anything with an even exponent, we expect to see this kind of open shape, this opening upward shape. It's kind of like a cereal bowl. Anything with cubed or an odd exponent, we expect to see this kind of S shape. So I'm going to click on the next slide. What you want to do is pause it and think to yourself, which is which? Do they match or do they need to be switched? All right. Okay, pause. All right, so I'm going to assume that you paused the video, you thought for a moment, and you said, you know what, I think this is a switch. X squared is this graph, 3x squared is this graph. The big difference between these two is if we have a larger number, the larger the number, the kind of steeper the graph. So I know it's not on here, but let's just say we wanted to graph 6x squared. We used an even larger coefficient. What we would expect to see is an even steeper graph. All right, so hopefully you match those up. They're both even exponents. They both have the same overall shape, but the bigger the coefficient, the steeper the line. All right, I'm going to go to the next slide. Be sure you hit pause. Okay, hit pause. All right, if you unpaused the video, what you should have said is, you know what, this one is a match. This is my x cubed graph. This is my negative x cubed graph. They don't need to be switched. Anything that's even has this S shape, and the most important thing to take away here is if you have a negative function, all it does is take each piece of the function and flip it upside down. So what used to be above is now below. What used to be below is now above, right? So this is x cubed, this is negative x cubed. The most important takeaway there is any function, doesn't matter what the basic shape is, including a negative out front just flips that upside down. All right, moving on. Moving on. Okay, if you paused the video and unpaused it, what you should have come to the conclusion is that these match. This is x to the fourth. This is x to the 10th. Just like the bigger the coefficient, the steeper the graph, the bigger the exponent, the steeper the graph. Smaller exponent, less steep graph. If, for example, I know it's not on here, but we had x to the 20th. Since it's even, we would still have this shape, but it would increase very, very quickly. All right. Moving on, be ready to pause. Okay, if you unpause these, hopefully you realize they needed to be switched. This is an inverse function, so a lot of our rules work backwards. In this case, the larger the exponent, the less steep the graph. Or the larger the numerator, the less steep the graph. The smaller the numerator, the more steep the graph. This happens for a very good mathematical reason. Let's just pick a number like 1. If you plug in 1, 1 over 1 is 1. So 1, 1. If you plug in 1, 5 over 1 is 5. So if you start with a larger numerator, you get a bigger y value, or you get a higher y value. You get higher y values dividing 5 divided by a number than 1 divided by a number. So you end up kind of farther above the x-axis, and it gives it this more spread out look to it. So the larger the numerator, the more spread out the graph. The smaller the numerator, the kind of tighter the graph, or the steeper the graph. And that's not just kind of just cause, it's for a reason. The bigger number divided by something gives you a bigger total, or kind of higher y values. The smaller number divided by something gives you a lower total, or kind of lower y values. All right, moving on, as soon as I get this erased. Moving on. All right, so hopefully you paused the video and you said, hey, look, the bigger the number, the more spread out the graph. The smaller the number, the less spread out the graph. Just basically doing the same thing as the last slide. Large numerator, kind of more spread out, higher y values. Smaller numerator, less spread out, steeper looking, lower y values. Moving on. Trying to move on. All right. Here we have another case of the biggest difference being a negative versus a positive. So one of the basic shapes we need to know is 1 over x squared has what I call volcano. It's just not a real math term. It's just a word to help us remember the shape. Volcano. And then negative 1 over x squared. Any negative flips the graph upside down. So we expect this to be kind of upside down volcano. This is a match. So you guys need to know this basic shape, you just need to know it. And then you need to know that to flip something upside down, you make it negative. Also, hey, before we go on, I should point out, the reason this is kind of symmetric is anything that uses even exponents only is always going to have this kind of balanced mirror image look, where everything on this side of the graph is a reflection of everything on this side of the graph and vice versa. Here, hey, we have an even exponent, it still works. This whole section is a horizontal reflection of this whole section. All right, now we'll move on. All right. Hopefully, when you unpause the video, you said, hey, look, bigger numerator, more spread out graph. So this is a switch. This one's kind of got a little more space to it. It increases, or it's less steep. Smaller numerator, tighter the graph. Really just the same principle we talked about last time we had two fractions. It's just the fact that they're squared gives them a volcano shape instead of the shape that we had. But it's still the same property. If we have a larger numerator, it's a larger number divided by x. That's going to lead to a larger y value, or a graph that's a little higher up at each value of x. Smaller numerator, lower total, lower y value for the exact same x value. Low y value because of a low numerator, high y value because of a higher numerator. All right, same deal. Bigger numerator, spread out. Smaller numerator, less spread out. And also, they're just that upside down volcano shape, that negative over x squared shape. Here the key to remember is this is the original version of an inverse function, and this is what upside down looks like. So just this is 3 over x, or 1 over x, or 5 over x, and then this is the reflection. This is the negative version. So this was a switch situation. All right. Here we have a case. I do not want you to think, oh, bigger numbers spread out. That's for numerators. This is just the larger the exponent, the kind of steeper the graph, the smaller the exponent, the less steep the graph. If you look at these curves, it should be pretty clear that this one is a lot steeper than this one. Kind of like we expected x to the 10th to be a lot steeper than x to the 4th. Same principle applies. Bigger exponent, steeper graph. Interesting. So this is a case of understanding that a negative exponent can be rewritten as a fraction. So this is really 1 over x squared. So this is volcano. This is really 1 over x to the first, which is 1 over x, which is our standard inverse function shape. All right, we did that one, we did that one. Oh, we got a couple left. All right, both of these are square roots. Here we have a bigger coefficient. Just like if you had y equals x and you multiplied by 5 and you had y equals 5x, you get a steeper line or a line that increased more quickly. Same thing is true here. We got a times 4, so we should have a steeper, kind of more quickly increasing graph. So this is a match. We got this guy goes with this guy goes with this guy. And also we just got to recognize that basic square root shape. So this is square root shape. And then multiply by 4 makes it increase more quickly. And then last. So the 0.5. 0.5 is another way of saying square root. So this is square root x. This is negative square root x. So they both should look the same. We got our square root function, and then we have our flipped over reflected version of our square root function. All right, I hope this helped a little bit. Really, the basics are, if you know something's negative, it should be upside down. Understand those basic shapes that create volcano, that create this shape, that create cubed. If you know kind of home base, and you understand how we can use negative numbers or how we can use larger numbers to change the graph, that's all there is to it.